Now I'm going to go over the explicit expression for the inverse of a matrix when it exists, and also I'm going to do a simple example. I will postpone until another video note a proof that this expression actually is the inverse. So I will simply state that the inverse of a matrix is equal to 1 over the determinant of the matrix times another matrix, which I will call the adjoint matrix. So a lot of this is terminology right here. So there are some related jargon terms. The minor, the cofactor matrix, and then finally the adjoint of a matrix. These are not completely universal, so let's be careful, and I'm being careful here that my definitions of these things agree with Greenberg's. So the minor is the matrix of subdeterminants of the n minus 1 by n minus 1 submatrices with a given row and column removed. So I will type what I mean. So for example, the 3, 5 component element of the minor of A is the determinant of the matrix of the n minus 1 by n minus 1 square matrix obtained from the original matrix A with the third row and the fifth column removed. Okay, that's as a specific example. We'll do an explicit example with an actual matrix in a little bit. The cofactor matrix is sometimes called the signed minor. So this is the signed minor, that is the G cofactor Ij is M Ij times -1 to the I plus j. So we have a checkerboard pattern of pluses and minuses in our matrix as usual. So for instance, if I have a 4 by 4 matrix, plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus, plus, those are the signs that the entries of the minor will be multiplied by to get to the cofactor. And then finally, there's the adjoint matrix, which is simply the transpose of the cofactor. Okay, so these are lots of words. I will go through and do a particular example. So example 10.6.2 in the book. The matrix A is 3, 2, minus 1, 0, 1, 4, 1, 5, minus 2. So eventually we want to compute the adjoint. First we would like to compute the minor, then we need to apply the appropriate pattern of plus and minus signs, and then we need to finally transpose it to get the adjoint. So the first step is to compute the determinant of A. So the determinant of A is equal negative 57. That's just a triple product. We could go through and do that. I will spare you the details. Now we need to compute the appropriate entries of the minor. So the adjoint, let's call it 80J. The 1, 1 entry of the adjoint is going to be negative 1 to the 1 plus 1 times the cofactor matrix 1, 1. I'm sorry, times the minor 1, 1 transpose, but the 1, 1 element is its own transpose. So that's going to be minus 1 squared, which is also known as 1, times the 1, 1 element of the minor. And the 1, 1 element of the minor is the determinant of the square submatrix that I get when I take the original matrix and I remove the first row and the first column. So that's the determinant of 1, 4, 5 minus 2, which is equal to negative 2 minus 20. That's equal to negative 22. And so the upshot is that the 1, 1 entry of the inverse matrix is equal to 1 over negative 57 times negative 22. If I want to look at the 1, 2 entry, that's equal to 1 over the determinant times the 1, 2 entry of the adjoint, but the 1, 2 entry of the adjoint, here's my dead A, is the 2, 1 entry of the minor with an appropriate sign. So negative 1 times 1 plus 2, that's 3. And then I have the 2, 1 entry of the minor. So M2, 1 is the determinant of the matrix that I get when I remove the second row and the first column. So this is equal to negative 4 minus negative 5. So that's minus 4 plus 5, which is equal to 1. But I have to multiply to go from the minor to the cofactor matrix. For the 2, 1 entry, I have to multiply by negative 1 to the 3, which is negative 1. So this entry is 1 over negative 57 times negative 1 cubed, which is also known as negative 1, times 1. So this entry is simply 1 over 57. No, it's not. Yes, it is, the 1, 2 entry. If I want to look at the 2, 1 entry, again, that's 1 over negative 57, negative 1 to the 2 plus 1 times the 2, 1 minor, and the 2, 1 minor is the determinant of the matrix, I'm sorry, the 1, 2 minor. That's the determinant of the matrix when I cross out the first row and the second column. So this is 3, 2, minus 1, 0, 1, 4, 1, 5, minus 2. And I need to cross out the, again, I'm looking for the 2, 1, sorry, the 1, 2 minor, which means I need to cross out the first row and the second column. So this is equal to negative 4. So that entry is simply negative 1 times negative 4 divided by negative 57, which is, doesn't particularly simplify, it's just 4 over 57. And we could go on and we could do this for the other 6 elements of that 3 by 3 matrix.